Functions are a really great way to chunk together parts of your code that are logically connected. And the better you can write functions, the better your code will be to read and understand later on. So with that in mind, let's talk about 7 techniques that you can use to write better R functions. We'll walk through easy things that you can implement immediately, even if you're just an R beginner, and we'll also move towards more advanced techniques that you can use when you want to take your functions further. So with that said, let's dive in. The first thing that I want to talk about is naming. That's really easy to change. Have a look at this function here. It's called CMP and it calculates the mean of the vector that we stick into it. And this CMP here really stands for calculate the mean of prices. But honestly, if I hadn't written this 5 minutes ago, I wouldn't even remember that this abbreviation is supposed to stand for that. But that's why I try to make sure that my function names are descriptive of what I try to do. So in this case, I could easily do write mean prices, and this will be my function name. And this is such an easy way to make your functions better, but it really helps. Stick to the rule of trying to make your function names into things that you do, and you'll have a much better time later on. After all, the tidyverse does exactly that. If you think about it, this verb like select or mutate, these are all things you do. Same thing goes for summarize, of course. So with these examples, I hope it becomes clear that it's a really good technique and you can easily adopt that. But you don't have to stop there. You don't have to stop at the function name. You could also take a minute to think about the argument names here. I kind of want to calculate the value or the mean prices. And honestly, now that I see this, we should write calculate and not create mean prices. So let's do calculate mean prices, and then back to the argument name, we can use, instead of something really generic as X, we could actually stick in something like prices. So of course our function then needs to work with the prices, but such a simple change doesn't cost you any effort, but it can help you understand your code more easily later on. And now of course, to see this in action, we could just take this function and stick in the numbers 1 through 5. So this vector, we could stick this into this, and then if we execute only the latter part, we see that, okay, it just calculates the mean of this. But it was a very simple example where naming just makes a function nicer. The logic inside of that function doesn't even matter for this easy step to implement. Another example where you see this in action is within the string R package. Let me just throw in here a code chunk that I've used in a previous video where we just take some vector full of text, and then at each step of our pipe chain, we do something. We trim white spaces, so that way we don't have these extra white spaces at the end of our text. Then we replace underscores with white spaces. Then we calculate the length, and then we sort stuff. The letter function isn't from the string R package, and you can immediately tell this via the fact that this doesn't start with str underscore like all the other functions here. Here you have str underscore inside of the function name. That's another way of really nice naming, because you can immediately remember that, okay, I need to work with strings, with text, then I will probably need a function that starts with str underscore. And if I kind of forgot the name of the function I'm looking for, I can just look through the list of auto completions. That's a really helpful technique, and you don't have to do this for packages only. You could also use this when you have a script that, or a couple of functions that work on one task within your automation, and then you have a couple of functions that work on another part of your automation. For example, when I work with AI code, I first need to run an OCR on a PDF document to get the text out of it, and then I put this into an LLM to extract stuff from it. And one function that does the first task, or all functions that does the first task, they can start with OCR underscore, and all the other functions that do the second task can start with LLM underscore. That way I would always have a way to find these functions, and I know into which step these functions belong. So that's a really neat technique, and here I've just used the string R package as an example. In contrast, if you compare this with the base R code that does exactly the same thing, you have different functions, and They all have meaningful names, of course. Here we have trim white space, here we have substitute, here we have n as a number of characters, and here we have sort again. So all of these things have meaningful names already, but the fact that these functions here all start with str underscore makes it much easier to find when you forgot a name. So there's that, naming conventions as a first step to make your functions better. And next, let's talk about another big thing inside of the R world, namely vectorization. For example, here I've put in another function that categorizes a price based on its value. So you stick a price in it, and if the value is larger than 50, this function returns expensive, and in all the other cases, it just returns normal. And if you then have this function, you can of course call it with a specific value, and then you'd get a corresponding output. So that's obviously an easy function. But watch what happens if I try to stick into this function not one number but multiple ones, say 30 and 60. So if I were to call this line, we see that we get an error. That's of course not great, and we'll fix that in a second, but here I kind of want to stress that if you write functions, you kind of always try to make your functions work with vectors that are longer than 1. So technically all of these numbers are also vectors of length 1, and in these examples they work, but you want to make sure that your functions also work with longer vectors. And the reason why is because vectorization, or these vectorized calculations, are so baked into R, and R users kind of expect that it works. In fact, I talked about this in one of my recent videos where I highlighted vectorization as a strength of R compared to what, say, Python does. If you're interested in that kind of stuff, you can check out this video here. But if you just want to know how to fix this function, then let's fix it already. So here we see that the error happens in the condition has length 1 when we have something in the if statement. What happens here is that we try to stick in multiple things in an if condition, and all of this is evaluated. So what happens here is that this vector is taken and it is set to greater than 50, and then we check what happens. We get a vector of trues and falses, and that's another example of vectorized calculations inside of R. But this if condition here expects exactly one condition, either false or true. So that's where the error comes from. And if you want to make this function work with multiple vectors or with multiple numbers, then you need to replace this if structure with something else that does if else. So in this case, you can use the if underscore else function that does exactly the same thing as we want, namely checking if something is true. And if it is true, then we stick in the value that we want to get in the true case. And in the other case, we stick in the thing that we want to have when the condition is not true. In that case, we can get rid of this stuff here. And now if we re-executed this function, we can still call it on these single values, but now we can also use vectors of length larger than 1. So that's neat, and this if else function is a really neat helper for this specific scenario where you kind of already have the thing that you're looking for, but you want to make sure that vectorized calculations also work. And now that I look at this function, I remember one more improvement that we can use here, and this brings me to trick number 3, which is avoid magic numbers. Magic numbers are just numbers that are thrown into your code. So here we have 50 as a magic number, and if you look into your code later on, you'll probably wonder, okay, what's the point of 50? Also, this function isn't really general enough because now you are stuck with this number 50. So an easy solution here is to put in an argument called threshold, set that to 50 as a default, and then you can just replace the 50 here. So you're left with this default magic number, which is fine, but you also have the option to set this to something else to break out of this fixed number. So if I just re-execute everything here, everything still works the same, but I could also say that, you know what, my threshold for something being labeled as expensive is now 100. And if I execute this stuff, then my price of 60 here, it is also labeled as normal. So that's my third thing that I'm mentioning here. And I totally act like I planned on this, but this is really just something I came up as I reviewed the function I wrote for this example. So really, I think now we're going for 8 techniques that will help you write better functions. But I guess who's counting? So now that we've worked with vectors, let's also work with data frames or tables. That brings us to tip number 4, which is to let the first argument of your function be the data frame. As an example of that, let's have a look at these two functions. This one function says append price category, which takes the data frame as a first argument, and then it has this threshold value, and then it uses this categorize price function with the price and the threshold, and then creates a new column called price category, and then this new data frame is returned, and then there's another function called calculate price stat that once again takes the data frame as the first arguments, and then has an argument called .by that is used inside of a summarize call to use as a grouping variable. So what we can do here is to create a table. We fill it just with a price column that has some random numbers using this uniform numbers generator. So if we re-execute this, we see that, okay, we always get a vector full of numbers or a data frame full of numbers, and then we can pass this to the append price category function that uses 50 as a threshold. And then we see that we get an error because I haven't sourced this stuff yet. So let me do that. And now this should work. And there you go. It does indeed work. We have a new column there now. And now what we can do is to chain this to the next step where we use the calculate price stats function and group by this new price category column. And now if we summarize like that, we see that we have values like that. And the reason this worked together so smoothly, these two separate steps, is because we had the data frame or the tibble as the first argument. And that way it really works nicely inside of pipe chains because this is a data frame. It is used as the first argument in the next function. So it is used inside of append price category. And this also returns a data frame, something that looks like this. And then this is used as the first argument in the next function, which also as the first argument has a data frame thing. So that's neat, really nice way of writing composable functions, or rather taking a logic and then separating it out into separate steps. And if all these functions that are one step start with the data frame as a first argument, you can compose this whole procedure by chaining together functions. That's neat. So now let's do something more technical. Let's do something more advanced, but I promise you it isn't that hard once you know the magic trick, but it really helps you to write even cooler functions. You see, when you have a chain here like this, you could just stick this into a different tidyverse function that works on data frames, and you, for example, use select and then get the price category, get it like so, and then you'd have selected that particular column. And the cool thing is that here you could use price category just like a normal thing. You don't have to wrap it into these quotation marks. Same thing would also be true with this summarize call that we have inside of our function. So here, if we were to just stick in price category for the grouping, this works. But the same thing doesn't really work when we try to use it here. So if we get rid of this stuff, we immediately see that, okay, this doesn't work. The object isn't found. And even if we get rid of this all off thing, which I had to put in there to work with strings inside of this .by argument, even if we do it like this, we see that, okay, this price category thing still cannot be found. And the reason why is because this price category isn't available anywhere in my variables. If I were to open up this tab here, we see that there is no variable called price category. So let me minimize this here once again and try to work out a way to make this magic happen so that we don't have to put in things into quotation marks. And the tidyverse has a really nice way of solving this particular thing. Namely, we wrap this into the so-called curly operator, and it is called like this because it consists out of two curly brackets, and then you just use this function as is, and now the magic works. Pretty sweet, isn't it? And the same thing also works with multiple categories. So for example, if I were to put in a step in between these two steps here and say, okay, mutate function, please calculate a new column called group, where you sample the values A and B so that we have different groups here. So really it just randomly samples A and B so that we have different group indicators. And then we could of course still summarize like we did before. But what we could also do is to use multiple things to summarize by. So let's also use our additional group column that we've just calculated. And there we see that, okay, things work exactly the same. That's pretty neat. And if we try to not use any grouping, something, then we see that, okay, this also works. Pretty nice, isn't it? It's really flexible, this technique of using the curly brackets, and honestly, once you know that there is this operator, it isn't that hard to pull off. For example, we could also enhance our append price category function here by not hard coding the column that our data frame needs to have. So for example, we could use the variable called price column and say, okay, in here we have the curly operator, use price column. Oh, I forgot a comma there. And then inside of this append price category, I could say, okay, the column that we're targeting to append the category is called price. Or we could also do price tags, whatever. Let's just call it like this. And then if we re-execute all of this, we see that this doesn't work because probably I forgot something. This part, of course, doesn't work because we also hard-coded the price here. So what we could do there is also do price column in here. Let's wrap this into curly brackets and then use this in here as well. And then we say, okay, we target the price tags column. And now if we re-execute everything, magic moment, unused argument, because we forgot to also put this in here. Otherwise it isn't an argument of that function. Another try. We didn't want to use price tags. We wanted to use price call in here. Probably really fun to see me debug this. That's what I get for trying things out on the fly. But you see, my point here is that things work. And you can use this curly operator to make your functions more general. And so that way you don't have to rely that the data frame really comes with the column price, because maybe some other input uses some other name, price tag, price value, whatever you can think of. So it's a really nice technique to know. Speaking about really nice techniques to know, there is this technique called hit the like button. You can use it to click on the like button of this video to let me and the algorithm know that you enjoy this kind of technical stuff. I know it was really cringe to use a really bad pun like this to make you engage with my video, but it really does help me. So if you want to do me a favor and you do enjoy this video, then I'd appreciate it if you hit the like button. So with that said, let's get back to the actual content. And the actual content that I want to cover here next is to modify or wrap this logic here into yet another function where we specify what the name of the grouping column will be. And you'll see why this is tricky, even though you now know the curly operator. So let's create a function. Let's call it append group column. And then let's use the data frame once again as the first argument so that we can use it in a chain. And then we use the column variable like so as a way to specify what the new column name will be. So we take this data frame and then we pass it to mutate like so. And now we want to use column instead of group here. And if we try this and use as column, we use group here, then this won't work. I already see the mistake, but still I want to show you so that in these rare instances where I actually see where my mistake will be, I can say in advance I knew this would happen. So really this doesn't work here because at this step this does work, but it adds the column name column. We haven't wrapped this actually into curly brackets. So let's try this instead. And now let's try this again, and this doesn't work because this didn't execute. And the reason why this didn't work, if I just try to execute this part here, we see that, okay, even if I force positron to execute this, it says that there is an unexpected equal sign after this curly bracket operator. And the reason why this happens is because when you use the curly operator to assign a column name, then you have to use the assignment operator, which has a colon in front of the equal sign. And now if I try to execute only this part, positron actually detects this as valid code, and without me forcing it, it executes it. And now if I try this, we see that things work out once again. So here now you can see that with this curly operator, we have named this column group, but we could also say this is letter because we only have letters in there. And then we'd have a column letter here. And then inside of our summarize call, we'd have to use this particular column name now. So once again, a simple technique once you know the magic trick. Speaking about magic tricks, and no, this isn't another way to make you engage with the like button. This time I actually want to show you one magic trick that the R language has baked into it. Namely, there is another operator called ... You have probably seen it already without actually knowing it yet, because if you look into the summarized documentation, for example, you see these ... operators, and it's always a placeholder of name value pairs like name and values that we always use, but they are used as a way to get instructions and then move it somewhere else. This is really the R way of taking an input and pushing it somewhere else.
We should take Bikini Bottom and push it somewhere else!
And with this magic way, you can use this exact thing to also make your functions able to get multiple instructions that are very variable or very diverse. Maybe that's a better way of saying it. Either way, let me show you how that works. For example, we can modify our calculate price stats with this curly operator. Let's just throw this at this position. And then we can say, okay, whatever comes at this specific location, so whatever isn't this .by operator or this .by argument, and whatever isn't this price column operator will then be transferred to wherever I use the ... next, and I use it inside of summarize because I already know that summarize can handle it. So with that, if I use it like so, then we still see that everything works like it previously did. But now we can also put in more instructions into our function call here. So what we could do is say the maximum is the maximum of the price text column. And now if we try this, we see that there is another column called max. We could do the same thing for the min column and say that is the minimum of the price text column. And that way we'd also get the minimum in there. So it's a really neat technique. You should use it carefully because there can be some weird debugging behaviors happening because this ... just eats up everything that doesn't fit into the arguments. Like if we look at this, if you throw in anything in there that isn't supposed to be used inside of summarize, if you throw in anything there and you don't have the ... at the correct position later on, then you might get weird errors, and this can be really error prone. So try to only use it in situations where you feel like, okay, I really just take this specific thing and push it into a way where I know this function that I'm using can handle that. So as always, with great power comes great responsibility. Alright, so we're almost at the end of the video. I want to show you one more technique that is a bit more involved because it requires you to set up more stuff, but it can help you to make your functions cleaner. And if you've seen one of my recent videos, then you know this technique and maybe this example already. But for all of you who haven't seen this, make sure to check it out. I think it's a really nice technique that makes your functions nicer. So let me throw in here another function that is completely separate from the examples we have covered before, and let me load the glue package because this function requires the glue function from this glue package, and really all it does is it analyzes patient data that is determined in terms of specific things like name, height, and so on, and then for this fake analysis it really just sticks together the things we put in there, and then if we analyze stuff we can call this function on different input values, and then things work as expected. Really here this is just a dummy example to show you what I want to show you next. Namely, the thing is, if I want to add more arguments or change arguments here, deciding that, you know what, I don't need the blood type in my analysis, I will just remove this stuff, and then if I call this function to save it as a new variable, then we see that, oh no, there are unused arguments because my function previously expected 5 arguments and now I'm only expecting 4, but all the instances where I've used this function until now, they kind of still have this extra argument. So I'd have to get in here and get rid of all of this stuff, which is a bit annoying and it's just too much effort. And then even if I do this, I of course also in my example have to get rid of the blood type here. And now if I do this, then you see that my function works again. So even if I change one thing in the function, I have to change stuff at all the other places where I changed things or where I used the function. And that's really annoying. One way to make this nicer is to use S7 classes to bundle together information that the function needs. So for that we can use the library S7, and if we execute this we have a way of specifying an S7 object. So now what I can do is to, in front of the analyze patient function, create a patient object or a new patient class, and it is just a bunch of properties that are specified via a list, saying that okay, there is a property called name, it's supposed to be a character, there's age, it's supposed to be an integer, there is height, it's supposed to be just a number, and so on. You get the idea. And there's even a mechanism to say that, you know what, once we specify all of these things, there is a way to calculate stuff immediately from that. Say in this case, we calculate the body mass index, which is a numeric number and is calculated via a function that operates on the object itself, dividing the weight by the height in centimeters and then applying this body mass index function. I'm not even sure if that's correct here. I just use it as a dummy example. Either way, I can create this patient and then I could create a patient with all the data I have. And now if I look at this, we see that there are all these @ signs here, and we've also seen in our code that it uses this @ signs to access attributes from the object itself. So we could do patient 1. It is named as follows, namely John Doe. And so what we could do in our function now is to get rid of all of these arguments and say there's only one argument, namely the patient object. And from this patient object, we gather the information via this @ sign here. So we stick in this thing here. And now if we execute this part, we see that we have a new function. And now inside of our function here, let me get rid of all the previous arguments. We can stick in patient 1. And now if we execute this, this works. We technically also do patients 1, 2, and 3. Let's do patient 1, 2, 3. Let's call them John Doe and Jane Doe. And then what we have here is really something we can use in here. And all of this still works. But now if I decide that, you know what, I don't need the height inside of my analysis or in this analyze patient function, then I just take this out. Let's just get rid of it. And then I re-execute this function so that it's updated. And now if I do this, my function just works. I didn't have to update any arguments for this function. So that's a really neat technique. And I covered a whole bunch of stuff that S7 can do in this video here. Hope it is this side. Last time I think I pointed always in this side. Either way, in one of these sides, there is a link popping up right about now that will lead you to that video if you're interested. And also with that, we're at the end of this video. I hope you enjoyed it. Make sure to hit the like button as I instructed you to. And also make sure to hit all of the other buttons that there are, which I think are mainly the subscribe button. But who knows, if you find some other cool buttons on YouTube, feel free to press them as well after the subscribe button, of course. I don't want you to go anywhere else before subscribing to this channel. So with that said, I hope you enjoyed this technical content. Let me know in the comments if I missed anything, like a cool technique that I should cover next. Also feel free to let me know if you enjoyed a particular thing, like particularly. And now with all of that said, I say thank you for watching and I'll see you next time.